Good afternoon, dear colleagues. USSC company has been on the market for 10 years, which is not a surprise because we have some other companies on the market like that. But for the first time, this project on the ICS information security, we've had our very first project implemented back in 2010. We began to dig into this field before it became a mainstream. We're based on Urals. We are surrounded by many industrial companies and organizations. This topic was relevant to us even before we got certain normative acts regulating the cybersecurity issues. Back in 2010, we first began to engage in cybersecurity. In 2013, we've already had a certain dedicated business line, and today we have several dozens of engineers in this department. They have competencies in automated management systems for technological processes and also some competencies in information security. These are very rare professionals, which are very rare find. Easy to lose, difficult to find. And by 2016, after accumulating a certain experience in accumulating ICS systems, we as a company realized that what we are lacking on the market is great products to ensure informational safety of the ICS, industry control systems. And by that time, we've also became a product developer. The name of the product development is VPK hardware and software system. And this is the very solution I would like to share with you about today. This is our path. This is our path on ensuring the ICS security. We have more and more challenges. Now we have the federal law number 187. So we have to build the information systems and so forth. And as of today, we have certain experience, and I would like to give you a very private case of building ICS system. It's a safety monitoring system. And having a certain academic frame of mind, I have to give you certain notions to make sure that we are speaking the same language. Monitoring is a certain observation process, and the security is also certain state or the property of the system where the system is being protected. So monitoring of the safety is basically evaluating this state of being protected over a certain period of time. But it's not as easy as it sounds. You've seen this picture on the internet. You have to know how to measure. And we have to answer three questions of how we are going to measure this state of protection. Like in what measures, in what metrics? And next, what do we do with these measurement outcomes? Okay, if we'll be measuring safety in some points, like 80 out of 100 is what? Is it good? Is it bad? Do we have to sound an alarm? Or quite the opposite, to be fully confident? I will try in a very methodological way to give you answers. First, why do we need security monitoring, cybersecurity monitoring? I have three main concepts. The first one is very trivial because effective Russian legislation requires you to do so. 239 regulation by the Federal Agency for Technical and Expert Control. They say, yes, it's security monitoring. And there's only one line. This regulation does not even tell us what they mean, but nevertheless, they say that this kind of activity has to be done by a commercial enterprise. Okay. Another more important factor is that the security is not a product; it's a process. And unless we watch the system, it will be degrading. For ICS systems, if we are not working, it works even more. Because if in your ICS system you have any problem with the main system, the first thing that people will be doing is switching off the firewalls and viruses, like this kind of fight and struggle. And the last thing, this monitoring, security monitoring, is needed because we need to see, for example, our system is malfunctioning despite all the measures. Nothing can be protected 100%. Incidents may happen, and we have to identify them in the proper time and to react timely. Next is what do we do? What do we do in terms of monitoring the security system? Monitoring is about not trying to meddle into the system under protection. We're not trying very proactively to apply certain measures of protection, like to block something, to switch something off. We simply observe the system and we assume that the system itself is inherently has some safety capabilities. Otherwise, what's the point to measure it? If the assumption is false, anything can happen. This system already has some protection devices and means, and the system is the system can has some communication channels. This notorious air gap is like a fantastic, so you have to have integration. But we are doing some kind of non-stop monitoring of any deviations from this model, which has been pre-described. But the only thing that we have to keep in mind here, that this model is always something simplified. It's a simple rendition of reality. It is not a given that the parameters that I've chosen and measurement of these parameters can tell us that, okay, the system is safe, nothing bad is happening in it. But since we can say that, on top of identifying certain deviations from the benchmark, we also have to collect as much information as possible to make sure that the system has some deviations or malfunctions in it. And first of all, we have to collect the events. We have to implement a very classical scheme. It is for the system of security monitoring. How does this solution look like in practice? As a main sensor, which is tracking the system, we use kicks for networks by Kaspersky lab, which is ensuring the traffic analysis for the technological segment to identify any anomalies in it. Some forbidden protocols, some known protocols, maybe some incorrect values, and so forth. But since this observation gives us just a part of the picture, on top of that, we also use this hardware and software complex data PK by CSB company, which is ensuring the additional collections of the security events and also configuration of separate components as a part of the ICS, which enables us to see the full picture and integrate data which we have obtained from the Kaspersky lab with a data PK solution, and we more clearly can see any incidents related to cybersecurity. It also takes availability of the top-tier system. And these two machines have identified any anomalies. We are pushing it up for the operator to work with this data, because again, the practice has shown that if we are looking into the real ICS of a real plant or factory, these kind of deviations or outliers will be many. Because, let's say, the factory networks usually have own specificities. It's not stable. Many things are happening in these networks, and the Kaspersky is seeing some deviations, and the data PK is also beginning to identify some deviations. Next is the network. At the moment, when we begin the work of building this ICS monitoring system,
которая представлена с левой части, да, слайда, что, во-первых, вот СУТП будет не такая уж и большая сеть. То есть СУТП — это что-то про вот какие-то там полевые шины, там что-то еще, они из Арнета только на картинках видели. Будет там 2 коммутатора, и все будет простенько. А второй момент, что нам всегда рассказывают, что СУТП — это так критично, это так серьезно, там надо согласовать.
Is that everybody's saying, so ICS, you need to compare it with everything. So in reality, first of all, it turned out that ICS is quite a big network. It was growing significantly over years. Dozens devices, lots of hubs, like a corporate network. The switch can be fixed under the table of some technician. And very quite roughly, and this is the reality, they just put it anywhere they want, so no network design involved. I would say there would be like a heaps of rings. For such networks, it's very difficult to build solutions. So then we have a task to design a monitoring system that will be able to actually collect data and to identify deviations. Initially, the network won't allow you to do monitoring. It won't be hierarchical. You won't find a kernel where all the traffic will be connected to, so you'll have to kind of make something up on the way. So there are three ways to do that. And the best one is to modernize ICS network, but this is very expensive. It's quite an ambitious goal. Not everybody will decide for it. To build a network in parallel, the network that will do monitoring only, this is much cheaper. The only blocking factor is to have additional physics. If we're talking about big enterprise, so they probably will have to fiber cables and all that, fiber optics and all that, so that you will need to get some approvals and stuff. It's not going to be easy. And the easiest one is to increase the number of sensors that monitor traffic. To put more sensors for kicks for networks, it will be cheaper. Of course, it will need some finances, but not as much. And the key conclusion is to not monitor 100% of traffic. So the structure is that you won't be able to put all traffic in the system, and it's going to be too expensive, too complex. So you probably have to see for yourself which traffic you don't need. So now tips and tricks. So what we have. First of all, this is the ring traffic, because many industrial solutions give you resilience net, failure resilient. So everything that goes from the switch to the ring. So from this one point, we can see the whole traffic of the ring. So we lose certain things that don't leave the switch, but we don't need to see it anyway. So that's why you choose the point of collection in order to see something that is interesting for you. Two PLCs don't talk to each other. So the communication will be with PLC or SCADA server. So we choose the point to see the traffic that we need. Then another pain point. In ICS system, we shouldn't rely on high technology, since different equipment is used, and this equipment usually cannot be tuned, fine-tuned, and even those that are dependent on logical loops. So we had a customer that, because of trying to make it more sophisticated, we actually managed to fail their system. So let's say that these are networks that are primitive, built on the equipment that can't do anything. And the final point, better to build a separate monitoring network than you rely on its capability only, and you won't depend on the technological network that you can't really control. So, after the monitoring network is designed, and you can collect the data, if we're talking about a big network of a plant, events, deviations, configurations, there are many events like that, maybe thousands alerts like that. So that's why with this incoming flow, you need to do something so that the operator could work with the data. There are three main processes that should be realized. First of all, prioritization. You need to prioritize the events. There may be several operators, and some operators can work with certain alerts. And we add data to the events that tell you what IP address it is, what MAC address it is, to enrich the data so that the operator wouldn't see just some unclear codes and who is hiding behind this. So they need to see who is behind this. So operator needs to work quicker. They have to stay there for the whole shift. So we should take off the load from their shoulders. So an example of such implementation is here on the slide. It's a real system, a real classification. As a result, the classification is clear for the customer. There is a lot of red here because the system is in the stage of implementation. So, but what they need to look at, they're looking for the green. So, in the upper level of the system, of the monitoring system, the requirements, the security requirements. Sometimes we think that they have the requirements, but oftentimes it's not. So we need to build some sort of center of corporate security. First of all, you'll be able to get IT system information. There may be many important things, components of ICSs. Here, you'll do integration with the system at the enterprise that automate processes. So information security department probably won't be the first one that wants to automate their systems. Maybe there are some other departments. And then later this SOC can be integrated with other means of ensuring security, including security monitoring. To give the operator full picture, you need specialized solutions. GRC solutions, good for that. E-platform solutions, also a very good additional solution for the system. This solution can be integrated with the Center of Russian Critical Infrastructure Security Requirements and with a particular department of the Russian Federal Security Service. Making the conclusion, summing it up, 5 points we need to take into account. First, don't put it off. The monitoring issue will arise. You need to ask this question to yourself and to people who will be doing the work on automation, because it will require time, additional finances. If this will come up in the middle of the project, that won't be pleasant. Second, this one I talked about the initial state. If we start monitoring of ICS, and there are no solutions, security solutions for ICS, so you always see the red screen. It's going to be bad. So first of all, you need to implement certain features, security features in the system, and then do monitoring. The third pain point. So don't come there with high technology. There's not going to be any dynamic routing. So it should be very simple. Also, 100% of the traffic won't be covered, at least at once. So that's why measure it up. And then what to do with the data that will go up. If on the top there is nothing to build on prioritization or enrichment or classification, then operator won't be able to do anything with this incoming flow. So they will be overloaded with the incoming traffic. So if you take into account these 5 points, kind of before you sail. It'll help you to do what you need to do. So that's it. Thank you very much.